everybody. I'm John Ellis, back for another episode of Optical Engineers at Work. With me is Sergey Sidorovich, a very experienced optical engineer, who's going to talk to us about optical inspection and a problem that he found with an optical inspection report from a manufacturer. If you're interested in this kind of content, please remember to like and subscribe. It helps the algorithm, helps more people find us, and encourages us to make more videos. Thanks. So Sergey, welcome again. Great to see you again today. I have here an inspection report for a lens that you designed. It's a manufacturer who has sent us this report to hopefully demonstrate to us that a lens element, rather than a multiple element lens, a specific lens element was made correctly. So I hope you can do, Sergey, is just talk us through quickly these different parameters that they're measuring, and it looks like that we have three different lenses that they tested for us, and they're listing the test instruments. But I want you to just quickly talk through these parameters and why they're important, what would be, bad about them being out of spec. And then we have kind of a surprise at the end of the discussion, because after you got this report, you noticed a problem, but we'll get to that later. So for now, Sergey, maybe you could just tell us about what each of these parameters mean and why they're important.
In each lens element, we have set or some kind of number of parameters that fully describe this lens. And at first line, this is a lens diameter. We define its diameter and potential error for the lens. Also, there are two radiuses of curvature for the lens. One of the radius can be equal 0 or infinity. This is a flat surface in this case. Also, we see center thickness. This is the distance between two spherical surfaces, or thickness of the lens. Surface quality defines number of scratches or defects at the surface of the lens. It is defined for each surface. Centration, it is measured in angle minutes or seconds sometimes, and this defined placement of the lens surface of curvature relative to the base surfaces of the lenses. Usually we define two base surfaces. It can be spherical surfaces, or it can be some kind of cylindrical surface or something else in the lens. Sometimes design of the lens can be very complex. Also we see flatness, right and left flatnesses. This is indication of the tolerances for the spherical surface curvature. And also the last line is the definition of the coating for the lens. And this lens should have coating that will ensure reflection less than 0.2% for the range of the wavelengths between 450 and 750 nanometers. So this is the list of the lens parameters. Yeah.
And is that a pretty typical anti-reflection coating specification? Is that kind of, would you call that standard, or is that highly specified, that particular value there?
10 years ago, this was perhaps pretty complex coating. Now time, it looks like very general coating. But we need to know that this coating is important, that each small diapason inside the defined diapason of wavelengths will correspond to this. This is some kind of general value for this diapason. And for some application, it is important to understand dependence of the reflections from the wavelengths. In this case, we can ask for the graph of this dependence and correct requirements after discussion with the lens supplier.
Okay. So most of these parameters are specific to the lens element. I guess from what you've taught me in the past, the diameter is pretty important for optomechanical reasons. If a lens was too big or too small and you put it in the assembly, then maybe the element would not be able to center relative to other elements in the system, or maybe would tilt. And so that's why that one is important. And of these, what, from an optical perspective, is there one that you think is most important? Is radius most important, or more important than centration, or are they all just important for different reasons?
It really depends on the application and placement of the assembly. Sometimes radius is very important, especially if we have no possibility to focus or to focus image somewhere. Sometimes tilt of the element is very important. It also depends on the lens form. It can be meniscus or positive lens or negative lens. A lot of things should be taken into account to understand what is important.
Okay. Interesting. So when you received this report, you weren't too happy about it because something within these numbers indicated to you that probably the factory had made a mistake in their measurement, and that made us nervous. Tell us about that.
While exploring the inspection report, I saw that radius error does not fit to flatnesses requirements for the tolerances. We defined tolerances for flatness as 15 Newton rings, and supplier decided to measure real radius of the manufactured lenses. We can see it in lines radius 1 and radius 2 for 3 samples. And also in the same time they measured flatness in Newton rings. And these numbers, real radius or difference between the defined radius and measured radius, should fit with the flatness. But in this case, these numbers do not correspond one to another. We have clear formula that show dependence on the number of Newton rings from the radius error. Okay. And in this case, this formula does not show required numbers of the, or shown number of the Newton rings.
Okay. So when you looked at this, was it immediately obvious, or you had to kind of run some calculations to see what this radius error was? Did it immediately look to you like that something was fishy, or was it only clear after you made some calculations?
At first sight, it looked not very suitable one to another. I mean, real radius and flatness tolerances. And then I decided to make additional calculations, put all these numbers into the formula and check if they work together.
So you just knew from your long work experience in optics, you could just see that something was a little bit wrong, and then
Yeah.
you tested it. Okay, great. So some real problem solving and investigation, and I'm sure the factory was embarrassed that you found this error after we pointed it out. I think they remeasured it, and I think everything wound up okay with this lens, and it worked. But I'm sure somebody at the factory didn't have a good morning when you pointed out that they were making mistakes in their test reports. So that was some good investigation. So thanks, Sergey. Thanks for explaining this to us. We appreciate your time. Thanks for everyone watching. Again, please like and subscribe if you're interested in this kind of content. And we'll be back another day for Optical Engineers at Work. Thanks, Sergey.
Thank you, John.